Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In this problem, we have two different particles of differing masses, but with the same charge that are going to enter the same mass spectrometer at the same speed. So ultimately what's going to happen is that these two particles are going to travel along different circular paths. And we're asked to figure out what the difference in the separation between the two particles is after they've already traveled through one half of a circle. So let's get a visualization of what this is going to look like. We're going to have a region of space with a uniform magnetic field in it through which our particles are going to travel. And they're going to travel with different radii. So we're going to have a magnetic field heading out of the page here. Each particle is going to enter with the same velocity v around here. Remember, they have the same charge, but they're going to have different masses. So let's say our carbon-12 isotope is going to travel along this circular path. So say something like this. And then let's say our carbon-13 particle is going to travel a different circular path. We know since the mass is higher and everything else is the same, that radius has to be larger, because if we look at our equation that defines the radii of these different circles in our mass spectrometer, it's given by this, remember? So since the carbon-13 isotope has a larger mass, larger m here, it's going to map out a larger radius. And so ultimately what we're looking for, right, is we have a circular path for our carbon-12 isotope. I'm going to use a 12 as a subscript here. That's the radius of the circular path for our carbon-12 isotope. And then the radius for our circular path for our carbon-13 isotope will be something like this. Ultimately, we're looking for this separation here, the difference between the two diameters of our different circles. So if we take the diameter of our carbon-13 circle and we just subtract it from the diameter of our carbon-12 circle, we're going to get this separation between the two isotopes in our mass spectrometer. So my diameters, of course, though, are twice the radii of our circles. So the diameter of the carbon-13 circle is going to be twice the radius of the carbon-13 circle, and the diameter of the carbon-12 circle is going to be twice the radius of the carbon-12 circle. So ultimately, the thing we're trying to find is twice the difference between the two radii. Now, we know how to find each radius because of our equation for the radius of a circular path of a charged particle going through a mass spectrometer, and so we just need to figure out those for each of our particles. For our carbon-12 particle, we're of course going to plug in the mass of the carbon-12 isotope, and everything else is the same between the two particles. They're both singly ionized, so they have a plus E charge, and they go through the same magnetic field with the same velocity. So if we plug everything in here, the mass of the carbon-12 isotope is 19.93 times 10 to the negative 27 kilograms. It's going through the mass spectrometer at a speed of 6.667 times 10 to the 5 meters per second. Divide this by the elementary charge, 1.6 times 10 to the negative 19 coulombs, and then we're going to also divide by the 0.8500 Tesla magnetic field. So overall, plug this in our calculator, we see that the radius that the carbon-12 atom travels through in our mass spectrometer is 0.09770 meters. Let me write this 7 just a little bit better. Okay. Now, I'm not going to plug in everything for the carbon-13 isotope, but I would just replace the mass, replace in this equation with the proper mass, and so we get a radius that should be a little larger, and it is. It's 0.1058 meters. So now, in order to find the diameter, all I have to do is plug everything back up into this equation. So let me just do that up here real quick. So in the end, what do we have? We have that the separation between the two is given by twice 0.1058 meters minus 0.09770 meters. Put it into our calculator, and then we see ultimately we have a separation distance of 1.63 times 10 to the negative 2 meters. And that is our answer.